Hello, my name is Ian. I'm a sales engineer at Gruntwork, the open source maintainers of terragrunt. And today I'm going to just give you a quick overview of why terragrunt. And the easiest way to start off for why terragrunt is like maybe why not. Terragrunt is a tool that wraps Terraform code. It does not replace it. It actually makes it a lot more scalable and easier to work with. When you think of tools like PyEnv or RVM or even tools like Brew to take it to an extreme. You know, there's things that we love and languages we love, but then there's tools we use to help us enjoy those languages even more. And a good example is something like, when I was learning Python, I wasn't really concerned with using PyEnv and just didn't really understand why I needed it. Then of course, quickly I realized like, oh, I need this. And now every time I need to write Python, I just set up a new Conda environment is what I use. Terraform is the same. Terraform is a tool, and then terragrunt is that same kind of decision. And then there's lots of times where you won't need Terraform. There's lots of tools out there that will instantiate infrastructure in a programming language you're familiar with, and those totally make sense for certain use cases. Like if I just need an S3 bucket for my service, and I don't really want to bother the infrastructure team with a pull request, I can just use my tool of choice and launch that S3 bucket. However, if you're on a team, like an SRE team or a DevOps team or an infrastructure team that's holding a pager or a platform team, Terraform becomes very valuable because it's crystal clear what it does. The issue is Terraform does not scale well by itself. So there's a couple answers to this. And one answer is Terraform workspaces. And if you're working on a small Terraform project, you're probably not using Terraform workspaces. You're probably only in one cloud, in one region, one environment. But once you need a workspace, you've sort of graduated to a non-trivial project of Terraform at this point. Workspaces aren't ideal for a number of reasons. I won't get into those because there's just plenty of opinions on that already. One answer to continue to use regular Terraform and avoid the workspace problem is to have a directory structure, something like this on the left, where I have a production account directory for US East 1, a production account directory for US West 1, same for EU West 1, and down the line I'd have a development and a staging and a UAT and a QA and load test and all these things. The issue is that this repeats lots and lots of code. Like what if I want my VPCs to all be on version 20? Well, I have to make 20 different updates. Or what if I want one to be on 20, but the rest to be on 19? Well, I still kind of have to make all those updates, and I don't have like flexibility there. I repeat a lot of code, especially around like AWS providers and state bucket in this case. So terragrunt is a tool to scale Terraform. It solves a lot of issues that Terraform has around, organization and doing string interpolation and things like that. So I'll stop talking and take a look. By the way, there's two ways I describe terragrunt. It's that if you think about a tree, and like here's sort of an example, if we just pretend this is a tree, your directories are the branches of that tree, and then terragrunt.htcl files, which are things that they're the leaves that actually call a Terraform module. Well, those are the leaves. So that's one way to think about terragrunt as a way to organize your code. And then additionally, it adds all of these features on top of it. So the easiest way to see all the features, I think, is to go to the terragrunt website. If you go to docs and then reference, I explain terragrunt like this to customers often, which is it adds, I think, 17 functions and 24 blocks or something like that. I lost count. But it really just adds some functions that I can call inside of a terragrunt.htcl file and also add some blocks and attributes that I can use. And the blocks are really interesting things like I can do dependencies. I can generate files on the fly. This is how I keep things dry, like my providers and my state buckets. So let's say I have a problem like this where I have lots of different regions and clouds and environments, and I don't want to have a main TF in every single file. I want to, these are all miniature root modules essentially. And additionally, I want to run these all at once. So let's take a look at some Terraform modules that we want to launch, and then we'll launch them using terragrunt. So here I've got, this is a fake module repo. It's in the gruntwork-io namespace. You can use this. It's actually really great for just testing out terragrunt because I don't have to wait for infrastructure to launch. I can just launch these fake ones. They do actually authenticate to AWS and do output, semi-realistic outputs. So they're good for just mockups exactly like this, where I want to just test authentication and patterns. I don't really need the VPC to be running. I just need something that looks like a VPC as far as values to be there. So I have all these modules, and I want to launch them across a bunch of different regions and teams and environments. So terragrunt as the tree can be thought of like this, where I can lay out my infrastructure as code repository in a way logically similar to how my cloud hierarchy works. So, this directory structure is systematically aligned to mirror the cloud setup. Sure. I have a cloud AWS. Inside of AWS, I have OUs. I also have organization level objects, but we'll skip that for now. I have OUs. Inside of OUs, I have accounts. Inside of accounts, I have regions. Inside of regions, I'll have teams and projects. And those teams and projects will own certain resources. And you see Aurora, EKS, VPC. Funny enough, that maps here. Again, this is just an example. This is an extreme example. So it's meant to just demonstrate what you can do with terragrunt, that it's really customizable. Not that this is like the best way to go about it. I would say have a mono repo for each cloud. Anywho, I can go on down the line where I've got the same with Azure, right? I can represent it with a management group, and then a subscription, then a resource group, then teams, and then those resources. Same with GCP. And these all have different hierarchies, but I can still make them familiar to people who are familiar with these clouds. Like I can actually click through the directory structure, and we'll actually see the directory structure, right? The next little bit is here's just this repo in tree form, and I see that same thing. I have a workloads OU that has a development account inside of it. And that OU has some values. So if we look at this, I should have made this a little different where the files are on top. But at these levels where I have things like OU, there's values at this level that I want to maintain, like the name of the OU and maybe some other stuff. Same with the account. Like this development account is a directory, but maybe I want to attach some metadata to it. That's like, here's a development account ID, some other things. Same with the region. There's region values I need, maybe even the region name. The team might have some values they need, and then those all will get passed down hierarchically to these modules. So my Aurora module, which is pretty neat, can look at this team directory and it's like, oh, what values am I a part of for this team? Oh, what values am I a part of for US West 2? Oh, what values am I a part of for the development account, workloads? And then where do I get my provider from would actually be AWS in my state bucket. So that's how this works, is that from right to left, I can consume values depending on where I am in this tree. AWS data, though, is interesting because if we look, this is in GCP inside the SRE projects folder, inside the project called observability, inside of a subdirectory just called Grafana for organizational purposes. Again, totally customizable. And then there's this module we're calling called AWS data. So this one is actually even cooler because it ends up going all the way up and around and actually pulls out values from all the way in here. It actually pulls it out specifically from this VPC2 module right here. And how does that work? Well, it all happens because we have these HCL files like account.hcl and OU and provider, but a very special type of HCL file called a terragrunt.hcl file. And I'll just skip ahead and show you that interesting kind of call around. Like we can break down a terragrunt.hcl file right now. So here we go. This is just an explainer on that. Like, oh, I'm in GCP. I want to get a value out of AWS. How do I do it without doing a remote state call or some wacky thing? So if I look, we're in this same path. GCP, SRE projects, observability, Grafana, and then for some reason the Grafana project needs AWS data. It needs a VPC ID, so fine. So remember, there's files like, in this case for GCP, I called it current, and this is just the current project. And it's like, okay, the namespace is Grafana and the environment's production. If I go to this project, there's a project HCL here, and this has, the project, I guess, short name, ID, and the region. So this is to set up the provider. If I go to SRE projects, I think this is empty. So yeah, there's nothing in here. And GCP has my dry provider setup. So what happens is every time I import this providers.hcl, what happens is a providers.tf is generated for me. So if we look, this is totally just parameterized. Like depending on where I am in the directory structure will tell me what my provider configuration looks like. So that's cool. Yeah, so if we look, we can see how that happens. Here I am calling a Terraform module. Remember, we're at, these final boxes on the far right-hand side represent actual Terraform modules. So in this case, I'm calling it AWS data because that's the name of the directory, but it's really just a silly module I have called null input output. It does nothing. One of the blocks that terragrunt introduces is called a dependency block, and it really just says deploy these in a certain order, and also I'm able to pull out values from them because it not only does that dependency move where it's like this has to exist before you launch it, it also introduces a new namespace where I can say, okay, this dependency namespace has a block in it called AWS VPC production US East 1. Oh, cool, that matches. Oh, it has outputs, and one of those outputs is the ID. So when I run this file, this terragrunt file, it's going to say, hello from AWS. And we can just do this right now. And actually, it even has this concept of mock outputs. And we'll just do this instead. I'm going to delete this, and we'll just pull down the change just to do this in real time. So I'll commit this, and we'll commit it to main. And now I'm going to go over to my, pull this out. I'm going to GCP, SRE projects, project observability, Grafana, AWS data. Cool. So I can be in this directory, and actually I'm going to authenticate really quickly. If I look at the README, it'll tell me what I need to do to authenticate. So if I look really quickly, I'm just going to scroll down. Okay, so in this case, to get to the G-Cloud, I'm going to run this command, and then I'm going to run this command to get my AWS values out of there. So I'm going to pause while I authenticate, and I'll be back in 2 seconds. Okay, so I've authenticated to both. I'm still going to wrap these in the, I'm sure there's an AWS Vault thing for G-Cloud. I'm just not aware of it. But I always wrap my commands in AWS Vault because it's just in my history I can see, what account was I pointed at. And of course, I could actually force the terragrunt to only be able to run in certain accounts. That's actually in this repo. It's just commented out in the providers.htcl file. But there's a note on how to do that. So anyways, I'm just going to run this command. And actually, we can just do an apply. What the heck? So this is saying, hey, your multi-cloud GCP, Project Ollie, Grafana, AWS data depends on this module in AWS. And do I want to run? And I can optionally run it or not run it. And I could say yes or no. I'll say yes. So what's interesting is that this is going to launch a VPC because I need it because to get this AWS data, I need a VPC. But what's cool is I can get away with running this only for plan and things like it. So if this, we'll just back up really quickly. I'll say no, just for fun. So if I say apply and then say no, this should fail. And it does, as we expect, because it's not possible. This is saying, hey, to do this thing for anything other than a validator plan, this VPC needs to exist. But I could do a plan, and this will run just fine. So same thing, yes, I do want to do the external dependency thing. Actually, I can say no, and it should still work because I was able to stub in this value. So if I'm iterating on this module and this VPC doesn't exist yet, I can still, this value just comes from this mock outputs right here. So this is pretty neat. And there's all sorts of tricks I can do about pinning versions to different, let's say I wanted to pin this to, I don't know if this is version or not. I'll pick on another one. I just want to pin my specific development US West 2 Team A VPC to, this is on example right now. I'll just pin it to v0.0.5. And I can commit this right in. So that's cool. But I could also abstract all of this away and just say, oh, you know what? I'll just make this a variable and make all of my modules inherit that. And we'll take a look at that in a second. Just to show you really quickly, again, the power of running terragrunt is that I have maximum control over what we just saw, very manually, but I was able to dictate how the plan kind of went through. Was it going to launch this thing? Yes or no? All that jazz. It's just pretty neat. It gives you really maximum control instead of this strict paradigm. In this case, I just cd to the root of this file system. So I'm writing here now, which is, it does have a terragrunt.htcl file. And what's neat is I'm saying here, like, hey, across all my clouds and all my environments, there's a value that I want everyone to be able to access. And I can do that. And this is really not the best way to do it. I just thought it's an interesting example of using a root terragrunt.htcl file for multiple clouds. So I can do something like this and say, okay, cool. And this is going to apply every single module in every single region, in every single cloud. We can see that it even grouped it by dependency. And if we think about it, well, like Aurora and EKS, they need VPCs to run in, so the VPCs have to run first. And cool, here's those fake modules running. They do actually authenticate to the respective clouds. Oh, here's a neat one that we can do with Terragrunt. So if we look how these tags are constructed, I can show you how they're constructed, is that every Terraform resource for AWS, or I guess all of them, is sharing this provider. And I set up these default values. And okay, here's that company ID. We saw that was in the root, so that like merged them. And then namespace and owner, and that's owner's SRE. Like, okay, because if we look, and I'll flip to find, you know, we're probably going through, oh, here we go, EKS cluster, perfect. That's the VPC one. Where's my EKS cluster? Here we go. So here are the tags on an EKS cluster. And if we go look, I don't want to, you know, this is really just introducing more Terragrunt functions where how do I import all of these values? So remember how I said that we need to annotate the different kind of these directories, like they all have values at certain pieces of them? Let's go look at the EKS cluster example. We'll do it in production. They're all the same. So team A has a bunch of team values where it's like, okay, team name, namespace, environment, production. This one's development, but it's the same. Well, just go to development just for symmetry's sake. So US West 2, team A, EKS cluster. And this reads, it doesn't even have to explicitly, oh, it does, I'm sorry. It reads those team values, as well the provider reads those team values and is able to create these tags. So pretty cool. But remember the VPC one had SRE in there and networking instead of owner and namespace. Like that's the neat thing is I have this sort of cascading ability for values where I can say things like, yeah, by default, all of the tags are going to inherit, you know, they can inherit these values from my team values. Same with the region values, you know. But these are all overridable because if I look at the VPC module in my terragrunt.htcl file that I tell all the teams like, hey, if you need a VPC, just copy paste this. What I have is, okay, get that root terragrunt.htcl file to get this corporate tag value, get the provider. We've seen a lot of that. The provider's awesome. And get those team values because we like those to tag things with and name things. But I also use the merge function, which is a native Terraform function, to actually override them and then pass those into the module. So that's the quick overview of Terragrunt in this multi-cloud Terragrunt system, file system. You can certainly play with it. I'm going to pause the video, and then we're actually going to take a look at the Gruntwork reference architecture, which is an even more interesting view of how to use Terraform. So I'm going to pause the video, and I will be right back.